Yeah. Comments? Okay, even everybody. I'll get right into it. Just just addressing any question with respect to anything that's happening. It's clear what we do. Just have a group of topics. You get a practice sheet. It's all past paper questions again. We work it out. And then afterwards, we go through the past paper booklets and just work out any question on the topic that we did for the day. That's all. Right? So it's practice. You have the benefit of either doing it to time. I give the recommended time. There's a paper 2, section 1 and section 2. Right? So if you're here from 5:30, for example, you should have at least covered the first section. That's what would be normally required in the exam. All right? All right, okay. All right, let's begin. Question 1. And this is on algebra. Relations, functions, and graphs. And if you want to have an idea, it's an example of almost all different type of questions that you get. All right, so question 1. Okay, 1. Solve for x, that one. So you can just check your answers. You can also make corrections and give your marks if you wish. Give you an idea what's going on. Solve for x, where x is a real number. That's an example of an inequation or inequality. So x right. Now we're going to do this thing very efficiently, rather quickly, and I'll just ask if you have any problems. But we won't be able to go through it in a lot of detail because the task is to complete the question. Inequality. Now I'm doing it in a way that I'm imagining that we're doing it the exam. So you're not going to write a lot of words, a lot of explanations, right? So I'm just saying. So for example, you're doing the exam and you have this. Immediately expand the brackets. 2x minus 12 plus 3x less than or equal to 8. X is on one side, so you could say 2x plus 3x less than or equal to 8 plus 12. 5x less than or equal to 20. Dividing both sides by 5. Right? And it's also being divided by a positive. So the sign remains the same. So you get x to be less than or equal to 4. Thanks. That's the answer. That's the solution. And they're saying for part 2, right? Using a number line, show your solution. For the number line, I'm suggesting that you don't want it to be too complicated. It's okay as long as you have the 4. That's the x-axis. And you have less than or equal to, right? Less than or equal to. So it will be like this, and you shade here. All right. And that's the solution. Less than or equal to 4. Right? So you have 3 marks, 1 mark. Right. B. 1B. Still question 1. B. Factorize completely. 1. 3x minus 6y plus ax minus 2ay.
Sir, if I jump your second line, would I notice?
You mean if you go from here to here?
No, if I jump the third line.
Go from here to here? No problem. Right? No problem. The question was if you didn't have all the steps that are indirect, are you okay? You're okay. Right? You're good. Right? Here, factorizing by grouping, that's the look that you should be. All right. So immediately you could say 3 bracket x minus 2y. A bracket x minus 2y. What is common is x minus 2y. So you can have x minus 2y, 3 plus a, or you could have it as 3 plus a, x minus 2y. Right? That's the answer. Part 1. Part 2, that's factorization by grouping. Right? The exam, the paper is next week, Wednesday. Is it?
Yes,
good. So you have about 8-9 days, right? Productively, it still makes sense if you're practicing, right? Good revision would be to still go through the past papers, know how to do the questions, right? There's no, if you notice, these are typical. Most of the questions next week, Wednesday, will be typical. Every one of them, almost everyone, you're going to say it's something like it before. So the main thing is if you can do the things that you have seen before, generally. When I say see before, this could have been 3 or 5 or 2 is the same principle. All right, cool. Part 2. P squared minus 1. That's supposed to remind you immediately of difference of 2 squared. The answer is P plus 1, P minus 1. If some of us do it this way, this is also okay if you include this step. You want to have it as something squared minus something else squared. And then you get P plus 1, P minus 1. Or you could have the P minus 1, P plus 1. That's the answer. Right? So that's 1A, B, 1C, 1C. Expand and simplify. Expand and simplify. Right here. All right. Part C. Expand and simplify. 2k minus 3, k minus 2. 2k minus 3, k minus 2. Expand and simplify. 2k must multiply the k. 2k squared minus 4k. And multiply the 2k by k, 2k by minus 2. Minus 3k plus 6. And I'm getting 2k squared minus 7k plus 6. 2k squared minus 7k, sorry, not x. 7k plus 6. Okay? Can't be simplified any further. That's the answer. Okay? So give me a minute. Let's send you I get there. Sorry.
But you don't read it.
D, 1D. The lines, got one? Okay, watch this carefully. Simultaneous equation. 3x plus y is equal to 2. 4x minus 2y equal 6. They're saying show that the point of intersection is 1, negative 1. What that means, the equation for straight line can look like this. Just imagine you made y the subject. Then you get y equal minus 3x plus 2. So these are equations of straight lines. When you solve two equations simultaneously, the answer that you get, x and y, will represent where the lines be. Something to know. So really, what they're doing is asking you to solve these two simultaneously. Different methods, I use one. Remember, going through, you might use a different method. Cool. So one, I'm going to eliminate y. So I multiply the first one by 2. Remember, you have different methods. 6x plus 2y equal 4. This one, I rewrite it, or some people say multiply it by 1. Multiplying by 1 is the same as just rewriting the equation. 4x minus 2y equals 6. I want to eliminate y. I want to get rid of y. So I'm going to add equations. Adding equations. 6x plus 4x. 10x. Cancels. Equal 10. From this, x is going to be 10 divided by 10, which is 1. If x equal 1, I can substitute x equal 1 into any equation. So substituting, what I get? X equal 1 in equation 1. So what I get is, where I see x, I put 1. 3 times 1 plus y equal 2. And from there, you end up with y is equal to 2 minus 3, which is negative 1. So therefore, x equal 1, y equal minus 1. Or you could say the coordinates are 1, negative 1. 1, negative 1. Okay? Right. Yes, question.
When you eliminate is the one that you eliminate at the sign, you look at the plus or minus and the x.
Yeah, the question is, how do you know whether we add or subtract? You look at what you're eliminating. What you're eliminating in this case is y, and since the signs are different, you add. When the signs are different for what you're eliminating, you add equations. When the signs are the same for what you're eliminating, the unknown you're eliminating, when the signs are the same, you subtract. Okay? All right. So we continue. If you had a plus 2y and a plus 2y, you would subtract equation. Okay. Good. Question 2. All right, so that's 1. 2. Question 2. All right, A. Solve for P. Still algebra. 2P plus 5 minus 7 equal 4P. Expanding, we get 2P plus 10 minus 7 equal 4P. P is on one side. 2P minus 4P is equal to minus 10 plus 7. Different methods. You could simplify first. It's up to you. I get minus 2P to be equal to negative 3. Divide both sides by negative 2. A negative divided by a negative is a positive. So what we get is P to be equal to 3 over 2, 1.5 or 1.5. Right? Right. That's 2A. 2B. Right. 2B, part 1. Factorize 25m squared minus 1 is another difference of 2 squares. This is the same as 5m all squared minus 1 squared. You don't have to include a step. This is a perfect square. It's a 5m all squared. This is 1 squared. So the answer is 5m plus 1, 5m minus 1. 5m plus 1, 5m minus 1. Right? That's 2B. Right, if you just joining us, we're looking at practice set. We have question 2B part 2. 2B part 2. All right, 2B part 2 is an example of a quadratic factorization. Check it. 2n squared minus 3n minus 20. Factorize. So one method, multiply the n numbers, you get negative 40. Negative 40. You want two numbers that multiply to give negative 40, and when you add, you get negative 3. So you use negative 8, positive 5. Then you split the middle term according to these numbers to get negative 8n plus 5n minus 20. It doesn't matter which one you put first, 5n or negative 8. Then you factorize by grouping 2n, n minus 4, plus 5, n minus 4. So what we end up getting is n minus 4, 2n plus 5, or 2n plus 5 times n minus 4. That's 2b part 2. 2b part 2. 2c. 2c says a candy store packages lollipops and toffees in bags for sale. 5 lollipops and 12 toffees have a mass of 61 grams. 10 lollipops and 13 toffees have a mass of 89 grams. If the mass of one lollipop is x and the mass of one toffee is y, write down two equations. So you're going to get 5x plus 12y equal 61. And then 10x plus 13y equal 80. 9. So they're saying there are 2 equations, 1, 2. Right. And based on that, they ask you to calculate the mass of 1 lollipop and 1 toffee. So this is actually another simultaneous equation question. Right? Moving this. Right? So 2C part 2. 2C part 2. What then I'm getting is calculate the mass of 1 lollipop. So let's say we want to get rid of this is an example. We have the same sign. I could get rid of x by multiplying the first 1 by 10. So I get 50x plus 120y equal 610. Multiply the second one by 5. 50x plus 65y equal 445. 445. Right? In this case now, we're getting rid of x. The signs are the same. We subtract. Subtracting, what you end up getting here is 55y to be equal to 165. Y is 165 divided by 55, which is 3. Y is equal to 3. Right? Why they gave us this big number? Max. Right? Right. Good. Yes, let's not. 2, right? Oh, okay, I understand what you're saying. Right. You agree? Yeah, the easiest thing will be to multiply this by 2. I agree completely. I understand your question. Right? Yeah. No, I agree completely. Hope everybody got that. Why get these big numbers when you could just multiply by 2? Yeah. I agree. No problem. Next. Substitute. Right. Work with me though, right? Want to be extremely efficient, so want to look at discipline in terms of the communication. This thing now is also work it out and move. Right? Yes, you can ask, because that's a very relevant question. The question was, why not just multiply this by 2 and then you get 10 and 10? That is exactly what would be good to do. Okay? But once you do the right thing, you still arrive at the answer. You should get y equals 3. Substituting y equals 3 in equation, say 1, we get 5 times 3. No. 5x plus 12 times 3 equal 61. And that's 5x plus 36 equals 61 equals 61 minus 36, which is 25. 25. Right? And then x then is 25 over 5, which is 5. So therefore, the answer is A. What's the price? Mass of 1 lollipop? $3. And the price of, which one is the lollipop? $5. And the price of 1 toffee is $3. Be careful. Make sure you answer the question there. Right. Gram mass? Why? I have 1 more week. Yes, man. 5 grams. 3 grams. I'm gonna need to bring my glasses. Can you see the price? All right, good. All right. 3. Question 3. A. Make R the subject, part 1. R minus H equal, is that RH? Right. said make R the subject. So the first thing you want to do is to get all the R's on one side. So you go, okay, R minus RH equal, take this over H. Factor out the R. R, 1 minus H is equal to H. Divide both sides by 1 minus H. So you end up getting, let me just show it. I'm saying you're dividing by 1 minus H, both sides. The objective is to get rid of this. So R equals H over 1 minus H. Right? Part 2. V equals pi R squared H. Divide both sides by pi H. Divide both sides by pi H. So you get V over pi H equals pi R squared H over pi H. What is the objective? I want R squared on one side. So the pi and the H cancel. Hopefully this is clear. So you're getting V over pi H equal R squared. To get R out of R squared, you find a square root. So what you get is the square root of V over pi H equal R. Right? But you don't want to write R. Sorry, you don't want to write R. Come again. V over pi H. Square root of all of that is equal to R. Or R equal square root of V over pi H. Yes, question.
Why is it try to get no? This is 3A.
3A. Which one?
Why never divide to bring over R? Why minus I?
You write which line? This line.
Yes, sir.
Why did I?
Why don't you divide? Like why never put this step over R to cancel it?
Okay. Because good question. If you put this over R to get rid of the R here, you're gonna end up with the R on the here. Because whatever you do to one side, you don't have to do to the other side. So in other words, if you cancel the R here, right? If you divide this side by R and you get H, you have to divide this by R. No problem, you get. No, you still have to divide H by R. So you end up with 1 minus H over R equal H, and then you still have to go and get rid of the fraction. You understand? All right, good. Yes. Question? Yes, we do. Anyone don't get? Anyone don't get one of these? Sorry.
Sure.
John, is it? Are the twins? See if we can. This one? 2016? Most which one? Most which one? Look. What's it?
2000. You share 2000.
Ready again. 3B. Okay. Three B. Let's go. The function f and g, that's the one we're doing. F of x is 2x plus 5. G of x is x minus 3 over 2. One. Yeah. I don't know. Right? Find F inverse of 19. You have some different methods. One is to find F inverse of x first. If this is f of x equal to x plus 5, right? All right, excuse me, hello? Yeah, not generally, everybody. As you keep focus. And we'll go through it quickly, okay? Right, if you have a challenge, just raise your hand and I'll answer the question. Right? We just want to be efficient. Understand? Thanks. All right. So f of x is 2x plus 5. You have different methods. I'll show you one. One which some students use. They let y to equal to 2x plus 5. And then interchange x and y. X equal 2y plus 5. Make y the subject. X minus 5 equal 2y. Divide both sides by 2. X minus 5 over 2 equal y. Write down the inverse, or you'd say y is equal to x minus 5 over 2. So the inverse is really x minus 5 over 2. Yes, and I agree, there are different methods for doing this. Now, this is not finished because you're trying to find f inverse of 19. Right, so f inverse of 19 would be substituting 19 inside here, so you get 19 minus 5 over 2. So the answer is 14 over 2, which is 7. Right? Okay, that's the answer. So one method is find the inverse function and then substitute 19. 2, find gf of 3. Most of us will find f of 3 first using the f function. 2 times 3 plus 5. You get 6 plus 5, 11. So that g f of 3 then will be the same as g of 11. You don't have to write these steps. Put in 11 inside here. So you get 11 minus 3 over 2. So it's 8 over 2, which is 4. So that's the answer. Right? Right. Right. That's question 3 completed. No, there's a part D. Right, 3D. 3D, right? C? There's a C?
Yeah.
Okay. 3C. A star B is equal to A squared minus B. Then 5 star 2. You could look at A being 5, B being 2. So it will be 5 squared minus 2, which is 25 minus 2, which is 23. That's the answer. Right. (3D). Simplify, express the answer as a single fraction, 2m over n minus 5m over 3n. LCM can use 3n, right? 3n is the LCM, because n can go into n. n into 3n is 3, so it's going to be 3 times 2n, the 2n, minus 1, 3n into 3n is 1 times the 5n. Or you could use brackets, so what you end up getting is 6n minus 5m over 3n, so the answer is m over 3n, and that's the answer. Right? That's right. Right, so there you have a few algebra type questions. If you want to have a good idea what kind of questions they can set, a good idea is to go through all the past papers. Right? At this time, based on the time left, it's not a very good idea to go through the booklets, the past papers that you have. You know, section by section, and question was asked, why not just do the total exam? You must know the section that you believe you want practicing. So it's all your choice. Okay, so what we're saying is, just for this week, every day, we'll have something like this. You can practice, then we'll work it out, and then after class, we'll just pick up the past paper booklet and say 2016, 2015, 2014, and go right through doing questions on this. Okay? You can just check what makes sense to you. All right. Question 4. Question 4. So going into graphs. X, y for the function y equal x squared minus 2x minus 3. Before you even go ahead and fill out a table, you should be able to recognize this as a quadratic function. The coefficient of x squared, when it's positive, you get a smiley curve. Positive x squared, smile, negative x squared, you get a frown, right? Okay, so this, before you even draw it, you know that x squared will have a smile minimum. If it was a negative x squared, you get a maximum or from. Okay? Positive is smile, right? From 1. Copy and complete the table. Part 1, x, y. We're going from -2 to 4. That's a -2, 5. In the exam, if you find you're not so sure, you could substitute one of their values and see if you get it. But, right? You don't have much time in the exam, but if you're not so sure, try one of theirs. Right? -1, 0, 1, 2, 3, 4. Right? Okay. Sorry. Excellent. All right. 0, -3, 1, -4, 3, 0, 4, 3. So just 2, 4 is fine. So it's just 2 unknowns, 2 values in it. Right. So when x is -1, you want to find the value of y, so you substitute in. Y equal -1 squared minus 2 times -1 minus 3. So what you end up getting is 1 plus 2 minus 3, which is 0. So when x equal -1, y equal 0. Right? Other one, when x equal 2, y is equal to 2 squared minus 2 times 2 minus 3. So y is equal to 4 minus 4 minus 3, which is minus 3. Right here is minus 3. Right? Right. It's not every time you're able to see the symmetric of the quadratic so straightforward, but this one is very straightforward. The symmetry is there. 5, 5, 0, 0, -3, -3. That's a symmetry. Right? Okay, part 2. Part 2, this is an example of a quadratic graph. Part B, is 3B. No, this is not 3, this is 4B, sorry. 4B. And this was 4A. So check your answers there. using a scale of 2 centimeters to 1 unit on the X and 1 to 1 on the Y. Plot the points, draw the graph. Okay? Plot the points, draw the graph. Now, just a little thing with the graphs. If you look at it, X values going from -2 to 4. Y values going from, say, -4 to 5. That means a line, your axis would be almost like a little cross. This is a sketch. I'm just saying, based on what I see here, this is my graph paper. -2 to 4. And then you have like -4 to 5. Your axis will be somewhere like that. So you have values of X going from -2 to 4 and values of Y going from -4 to 5. So in other words, you need negative and positive X values and Y values. Right? And obviously, when you draw, you want to make sure the graph can hold. You don't want to wait until you plot the curve and they realize it didn't make sense. So your graph, obviously this is a sketch, right? Let's say this is -2. Then I'm saying 1 centimeter to 1 unit. If let's say this is 1 centimeter, then this will be -1, 0. So this will be axis, right? 0, 1, 2, 3, 4, 5. Well, you don't need to go to 5. It's a sketch. You need to go from -2 to 4. And then vertically, using 1 centimeter to 1 unit. So this will be like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The scale vertically is different. The scale is 1 centimeter to 1 unit. This is 2 centimeters to 1 unit. I'm using this as a 1 centimeter. So you go -1, -2, -3, -4, -5. Okay, make sure you get the scale. -2 goes to 5, somewhere here. X can work, a point with us like a circle. -1 goes to 0. 0 goes to -3, make sure you plot it properly. 1 goes to -4. 2 goes to -3, 3 to 0, 4 to 5. And your symmetry should be evident. You want a smooth curve passing through the points. Something like that. And that's it. Right? You can, on the graph paper, y equals x squared minus 2x minus 3. It's a quadratic graph where you have a minimum. When the x squared is positive, you get a minimum graph. Good. And that's 40 on graph paper. Label your axis, x-axis, y-axis. Write down the equation, y equal, or something I could say f of x equal, and that's it. So that is B. C, using your graph, estimate the value of y when x equals 3.5 using your graph. That means you're going for 3.5 here, x. And then what you're doing is carrying it up.
So 3.
Right? And you're reading off whatever you get on your diagram. Right? Okay. Right. So using your somebody who has the graph, you want to tell us what's a good 2? 2? Right. What they do is see. What they're going to do in the exam is just check if you're reading your graph properly. Okay. So it's y equal x squared minus 2x minus 3. You're looking for 3.5 here, right? Then you're using a line. Broken line is what you normally use with a ruler. And then you're carrying it across. And you should be getting something like 2.2. Yeah. 2.2 thereabouts would be okay, right? And based on the scale there, if you're getting, you should be able to get something like 2.2 or 2, right? So something around the region of 2.2 would be a good result. But you're using what you get. So for C, y is equal to, let's say 2.2 or thereabouts. Again? They ask you that? Or you just asking? Right. Oh, the calculation? No, I just substitute the 3.5 and see what the accurate answer is. Because that's sketch and that's all. But they did not ask you to use that. But of course, you could check it to see if the answer is near. But what they want to see is that you look for 3.5 up, across, and read out the value. So I'm getting y equal 2.2. You should be getting something like 2.2. What is 2.2, by the way? 2.2 is the first mark after 2. Because if 1 centimeter represents 1 unit and you have 5 boxes, 5 marks, and each one is 1/5 or 0.2. Right? Check that. So when you're counting, what I'm saying here, if you zoom in here, and this is 2, and this is 3, and you have 1, 2, 3, 4, 5. Then each one will be 0.2. You have 1, 2, 3, 4, 5. 5 divisions make 1. So each one is 1/5 or 0.2. So this will be 2.2, 2.4, 2.6, 2.8, 3. Okay? All right. So that's B. I think there was a question. That's it. You have another part too? Oh, yeah, more. Good. Good. 4D. Right. Okay, 4D. Right? 4D, A, B, C, D. The working, how do you show the working for C? Just remind you, the working is shown by identifying. You don't have to put this arrow with 3.5, but you're showing, drawing a line up and across, and then you're reading off the 2.2 here, or there. All right, part D now. Without further calculation, write down the equation of the axis of symmetry of the graph. The axis of symmetry is the mirror line. The mirror line passes through, and you're using ruler. That is the axis of symmetry, or the mirror line. A vertical line that crosses the x-axis at 1 has equation x equal 1. Vertical lines, x equal 1, x equal 2, etc. Right? So the answer is x equal 1. The equation of the line of symmetry is x equal 1. X equal 1. X equal 1. What is the line of symmetry? Passes through this point, which is the minimum point. Right. Estimate the minimum. No man, the one above. D. Above this. Question 4. Right. Estimate the minimum value of the function y. The minimum value of y would be here, the lowest point on the graph. You're carrying it across. And what you're getting is negative 4 point something? 4.2? I don't think it will be negative 4. No, shouldn't be negative 4 because it passed negative 4 and go down. It must turn after negative 4 unless you have a flat. Oh, is this one? Sorry. Push. Y equal negative 4. Minimum value. 3? Too many questions. Right. And you know what? They should have said estimate. It's not estimate. It's the exact value. There's no estimation there. Anyway, state the values of the solutions of the equation, watch it, x squared minus 2x minus 3 equals 0. Please. It's 1 mark. So this is no quadratic equation with formula or factorization. This is graph. What they're asking is this: how do you solve this equation using a graph? The left-hand side is the same as y. So all you're doing is looking for where y is equal to 0 on the graph. On the graph, y is equal to 0 at this point and this point. And then you read off the x values. The answers are x equal -1 and x equal 3. That's the answer. Just by the way, if they said solve the equation x squared minus 2x minus 3 equal 2, for example, what you do is look for where on the graph y value is 2. So you do like draw y equal 2 and find where the line meets. Okay, we're just working out straight and giving you the answers. So that's question 4. Question 5. Questions? Okay. All right. Moving. That was 4D. Moving. All right. Just a request from somebody online. Just a little patience. 3. We did this already. No, I just leave. Well, leave it here. We'll soon rub this out. 3D. There was just somebody who asked about this. Right? So repeat. 3D. 2m over n minus 5m over 3n. We said the LCM, so repeat, the LCM was 3n. I just rewrite in an answer. n into 3n is 3. 3 times 2n is 6n. Minus 3n into 3n is 1 times 5n is 5n. So you end up getting m over 3n. Okay? All right, so let's continue. Question 5. Huh? Question 5. Okay, question 5. The diagram shows a graph of a straight line passes through P, passes through Q. A. P. Careful, it's on the y-axis, so the coordinates are 0, 3. Q on the x-axis, so -2, 0. B. What is the gradient of the line segment PQ? We can use the formula y2 minus y1 over x2 minus x1. Or some of us know that you can use rise over run in getting from Q to P. Anyone can work. Using y2 minus y1, x1 y1, x2 y2, gradient is 0 minus 3 over -2 minus 0. That becomes -3 over -2, so the gradient is 3 over 2. That's the answer. Right? Questions that we're setting in these sessions are revision questions. They're all past paper questions, but there's nothing that's saying we think this is coming or that is coming. It's just trying to revise the top. That's all. Okay?
I leave off a negative.
I leave off a negative? Where?
-3.
Oh, it's -3 over -2, but a negative divided by a negative is a positive. So the answer is 3 over 2. Okay, run that again. I'm saying when you work it out, you get this. Negative 3 over negative 2. Negative divided by a negative is positive. So the answer is 3 over 2. 1.5. Positive. So in other words, this is not finished. You understand? Right. The negative 3 over 2 is incomplete. The best answer would be 3 over 2, 1.5, or 1.5, something like that. 2. Equation of a straight line. Now, you could write down this equation because you have the gradient and you have the y-intercept, which is 3. So the equation is y equal mx plus c, which is 3 over 2x plus 3. C is the y-intercept. So you could just write down the equation of the line to be y equal 3 over 2x plus c plus 3. M is 3 over 2 and c is 3. C is in the equation y equal mx plus c. C is the y-intercept, which means where the graph meets the y-axis. So if you know where the graph meets the y-axis, you could just write down the equation of the line. If you didn't, you would have put y equal 3 over 2x plus c. And then what you do is substitute the coordinates of one point to find c. For that method? Right. Five. Yes, you could. You could use 1.5. Right? You could use 1.5. Right. So the answer is y equal 3 over 2x plus 3. I'm going to do it. And just for this one alone, I'm going to do it again a longer way. What? How is it I can put 3 here? Because in the equation y equal mx plus c, m is the gradient and c is the y-intercept. What does y-intercept mean? Where the line crosses the y-axis. So since we know that the line crosses the y-axis at 3, and the gradient is 3 over 2 or 1.5, you could write down the equation. Right? I'm going to do it just one more time. But this way, a little longer. We know the gradient is 3 over 2 from here. So the equation is y equal 3 over 2x plus c. Right? Students do it this way. Then, there's a very important thing which says, if a point is on a line, then the coordinates supposed to work in the equation of the line. So since we know these 2 points are on the line, I could substitute the coordinates of any one of the points. Let's say I use this, for example, q. If I use q, I would get x equal minus 2 and y equal 0. So using q in the equation, look at what happens. Y is equal to 0 will be equal to 3 over 2 times negative 2 plus c. What you end up getting? 2 into negative 2 is negative 1. Times 3 is negative 3. Carry over the minus 3 and you end up with 3. So what would happen here is that 3 would be equal to c, or c equal 3. And the equation will go back to y equal 3 over 2x plus 3. So it still works out. Generally, to find the equation of a line, you need a gradient. If you have the gradient, you write down the equation. Y equal mx plus c, like this. To find c, substitute the coordinates of a point which is on the line. You have to make sure you're using a point on the line. So I use q, where x equals negative 2, y equals 0. So where I say y, I put 0, and where I say x, I put -2. And then I solve for c, and I got c to the 3. So you replace the c here and write the equation as y equals 3/2x plus 3. The only reason I could have just written down the equation one time was because we knew from the either from the diagram or from this point, we knew exactly where to cross the y-axis. You cross the y-axis at 3. In most cases, you won't be given this. And so you'd have to go and plug in the coordinates for a point on the line and find c. Right. Question? Oh, why? No, I don't put down the -2 where x is here, because this is what you call the general formula. What do you mean by the general equation of a line? It means any point that you pick on that line. If you put in x and you work it out over here, you get back the y. So it's a general, it's kind of like when you use what you call variation and you find the k, like in variation, they say you find the constant. When you find the constant, you have to be able to say the formula is y equals 2x squared, for example. You write back the y and the x, which are variables. Okay?
They never change.
No, variables change, the constant never change. But the variables change. For every other value of x, you get another value for y. So in this case, these don't change. This can't change because that is actually where the line meets the y-axis. This is the gradient. But remember what gradient means? Gradient means slope from left to right. This is 3/2 is saying when you go from left to right on this line, for every 2 you go across, you go up 3. Come again. The 3/2 as the gradient means for every 2 units you go across, the line goes up 3. When your gradient is positive, your line slopes upwards from left to right. The 3 is sometimes referred to as the rise, and the 2, the run. What we mean by that, the 2 is how many units you go to the right, and the 3 is how many units you go up. If it was a -3, it would tell you that you actually went 3 units down, and the line would slope downwards from your left to your right. Question?
Is the gradient the fraction?
No, the gradient could be 2. If the gradient is 2, you could reason that it's still a rational number. You could write it as 2/1. Repeat, if the gradient is 2, you can think of it as 2/1. And 2/1 would mean for every 1 you go across, you go up 2. Okay? Good. Continue. Right. Okay. C. Look at C now. Part C, this is a good question because we now have the equation of the line. I'll write it again. The equation of the line is y equals 3/2x plus 3. That's the equation. All I'm doing is rewriting. But here what I say now? They said the point -8t is on the line. So that means if -8t is on the line, what it means is I can put in the x and the y into the equation. Because if a point is on a line or a curve, the coordinates must work in the equation. So it means in this x equals -8 and y equal what? T. So plug it in, plug them in, put them in, so you get t, whereas the y comes out 3/2 times
Plus.
yeah, -8, you're right. -8 plus 3.
So -4 times 3.
2 into -8, -4. -12 plus 3 is -9. And that's the answer. But what was it? What was the principle the little thing used? If a line passes through a point, or if a point is on a line, then you're supposed to be able to substitute the x and y values into the equation of the line. So the answer is t equals -9. Yes?
So where -8 is on the x, when you draw the line, so -y on the
Right. It's not easy to see it on your diagram. But check it. Just imagine. Could you kind of picture where negative 8 would be on your graph? Way over here. So. And watch the line. It's obviously getting more and more negative.
So if the rise and roll, you get negative 8 then?
No, not the rise and roll. When you look for the negative 8 and carry it down, it will come down at negative 9. Right? Good. All right, for this one. Yes, I can. Okay. What we're saying is this. Once you have the equation of a line, and for example, suppose I put, let me look at this graph. Quickly, suppose you put x equal 4 here. What would you get y to be? X equal 4. 4? You'd say 3 over 2 times 4. 2 into 4 is 2. 2, 3 is 6, plus 3, 9. Now you see, if you could extend this line, just look at the line, and you look for 4. What it would mean is that where you see 4 and you go up to the line, it will be 9. You can see? What? But let's turn it around. Let's turn it around. Suppose I say, hold on, please. Suppose I say that there is a point which is on the line where the x value is negative 8. Watch it. If there's a point on the other side where the x value is negative 8, find the y value. You understand? It's on the line. Another way they could have said it is the x value for a point somewhere way over here is negative 8. Can you find the y value? Because we can see it on the graph. What would you do? You put x equal negative 8. 2 into negative 8 is negative 4 times 3. Negative 12 plus 3, you get negative 9. Where I got the 4? The 2. See there? 2 into negative 8. Right. What am I doing? Right. Why do I use the negative 8? To find it. Okay. All right, good. Continue. Yes. Yes. You're saying? You're asking? Okay. All right. Let me see. What do we do now? We found P. Okay. The line segment. Watch this now carefully. The line segment. This is part D. All right. The line segment AB, key word here, is perpendicular. So perpendicular and parallel lines. Parallel lines have the same gradients. If they said that the line was parallel to this line, then they'll have the same gradient. The first thing to do here, since it's perpendicular, you need to write down the gradient. When two lines are perpendicular and you have the gradient of one, to find the gradient of the other, you invert, change the signs. So the gradient of this new line, the line AB, is negative 2 over 3. Where did I get that? When two lines are parallel, the gradients are equal. When two lines are perpendicular, the gradient of the second one is the negative reciprocal, which is the same as inverting and changing the signs. Okay? Right. So the gradient is minus 2/3 for the new line. That's the line AB. Do we know the coordinates of A or B? We don't, but we know this line passes through 6, 2. So guess what now? You have the equation, which is y equal minus 2/3 x plus c. To find c, you're going to substitute 6, 2 in the equation. So in here, you're going to say now, using 6, 2. Using 6, 2. Why am I using 6, 2? Because I said the line passes through 6, 2. So where I see y, I'm going to put 2 equal minus 2/3 times x, which was 6, plus c. We're trying to find c. Is a different line? Different line. You have the gradient. How did I get the gradient? It's perpendicular to this one, to this one. The gradient of this one is 3 over 2. Since it's perpendicular, invert, change sign, negative reciprocal. If they had said it was parallel, I'll use back the 3 over 2. So the equation is y equals minus 2/3 x plus c. How do you find c? You have to substitute the coordinates of a point which is on the line that you want to find. You can't use p, you can't use q. Those are not on this new line, the line AB. So working this out, we get negative 4 plus c is equal to 2. So 2 plus, it means that we're going to get 2 plus 4 equals c.
C equals 6.
C equals 6. And the equation is y equals minus 2/3 x plus 6. That's coordinate geometry. Run it again. To find the equation of a line, you need a gradient and you need a point on the line. That's a general thing. Once you have the gradient, you write it in the form y equals mx plus c. Y equals mx plus c. Once you have y equals mx plus c, you put in your gradient. You cannot write down c in this case. So I could say, okay, couldn't you write down c here? You can't use this and write it down because this is not the y-intercept. The only time it would be the y-intercept is if this was a 0. Because 0, 2 would say it's on the y-axis. So what you end up getting is y equals minus 2/3 x plus c. To find c, a point is on a line. You can plug in the coordinates into the equation. Find c. Once you find c, then you write down the equation. And that's it. So that's an example of like a section 1. 5 questions on this particular topic. The ones around the other section normally will come in the second section. So if you're here from 5:30, that's what we have completed. Should have been done in around 80 minutes or thereabout. 80 minutes, it's around 1.5 hour and 20 minutes, and we did the answers. So what we're going to do now, and for the future, if anybody is interested, what I'm saying is I will release the paper earlier. Meaning so that you could, what you could do is, if you have a little time, maybe it's a lunchtime, you do section 2. And then maybe in the evening, if you're working, you could probably do the section 1 and then we discuss it. Right? I do enough. It could go past the time. In other words, if you did all of this, it would take up more of this time. But we want to not just do it. I want to give you a little time to practice and then to work out. Okay? All right. So, based on the time, you know, I did say 5:30 to 8:30. Want to cover at least the first section, but we can go through the second section. Paper 2, section 2, ready? This now is your choice because you know you have 2 out of 3. So you will determine which section you're doing in the second section. Right? I generally advise that the graph part is something you do. I tend to be able to come in the first section or the second section. Generally. Okay? All right. So, anybody got that chance to do the second section already? Don't reach here. Started. Let me see. How many questions are on the second section? 2? All right. Say what time. You want to just sit? You want to give it a time? Do it. I'm pretty sure most of you wouldn't be able, have been able to attend the 2 questions yet, right? All right. So suppose I say do it. You did say to 8:30, but you want to do it and then just maybe 8:45 work it out. Meaning I'm saying do it. Attend it. Attend it. What time class finished? Well, it's supposed to be 5:30 to 8:30, and then at 9, I'm going to take up the past paper booklet and just go through any questions on these topics. Okay? All right. Again, the class is really 5:30 to 8:30. When you do that, you'll have whatever I asked you to sit and do, we would review just like this. I gave some additional questions which ideally would have, right now, what I'd have done is just work out the two questions. You get me? You get me? Right. So I'm asking you to attempt them before I do them. So I'll give you 20 minutes and I'll do them. So we extend to 9. Okay? It's around 5, 6, 7. Is that around time? 9 o'clock if you can communicate with your daddy and your mommy. Take 20 minutes for the second section. Let's go. There you go. Ready? I'm sure you never do it yet. You attempt it before. I'll give you 20 minutes and then I'll work.
What other
H and K. Okay. Recently, for completing the square in the second section, for completing the square, now somebody asked me this question. Some students use a formula for completing the square. Right? Everybody remembers it? If you write it in the form x plus h squared plus k, h equal b over 2a. Some students use this formula. Some students use a different method. Right. If you don't know, if you have another method and you have been using this, fine. This. Yeah, I find it very. Okay. All right, let's see what's happening. Let's see what's happening. See what's happening. Try and do it practical here. Let me see. Yes, I suggest work it out. Work out. There are 2 questions that should not take around half an hour. So work them out. Yeah, go ahead.
Sorry. So the top part of it is the value for x. And then we have to find
What's the grade of this man? Because it's working. That's great. So you how do you rank? What would you rank an ingredient? This is the thing. Yeah. Let's see. Right. Well, since this line passed through this point, we can substitute these into right. Now 6 times 6 plus
And then when you get this,
Sorry, what's happening?
see? No, it's continue. Continue. What do you want, a paper? Basic one. Really need for the same time. Sorry. So draw the line on that. This one. Sixteen. This is good. But it doesn't need to multiply by 16. All right. Not missing anything we did. We did paper 2, section 1, and went through the answers. So the section 2 and past paper workout, we're going to do it after, since none of our students didn't get to do it. Ask you to attempt first, and then we can do it. In terms of the workout, because you have the link on the stream, I'm saying there's nothing you can go home and you can just chip in any way you want at any time. Right? Right. I'm here, I'm doing it right here. So if you want to stay, it's fine. We're going to be doing the section 2, paper 2, section 2 shortly. And then I'm just working out past papers on the topic from the past paper booklet. Too late? I'll start working out now?
Yes, sir. Yes, sir.
Ready?
Yeah.
I'll work it out now. I'm working out this thing as we go along, okay? Right. Okay, the question is, when are we doing this part? Let's do it now. No. Okay, paper 2, section 2. So I'll. Ready? Question 6. A. All right, let's get through this. Question 6A. Right? Remember, it's all recorded, so when you go home. Another paper, yes. So maybe when you're on your way home, you could do it on the bus or in the car, and then by the time you reach home, you'll sick. Right? How are you doing? Have a good night? Yes, yes? Yes, good night, yes. All right, solve simultaneously. Remember now, this is paper 2, section 2. It's optional. This simultaneous equation will not appear in the first section. This is not elimination. And you must know what you're doing. You must have your formula for which section, what you're doing. 2x plus y equals 7. X squared minus xy equals 6. So this cannot be solved by elimination. This is one that you solve by substitution. Normally, you look for the linear one. The linear one is the one that does not x, y, or x squared. Make either x the subject or y the subject. The one that you find easier. Like in this case, right. From equation 1, we could say y equals 7 minus 2x. Right? And now what I call this equation 3, where you don't have. Where did I get this from? I'm using one of the two equations to make one of the unknowns the subject. The easiest one to make the subject in this case is y. If you try x, you end up with some fractions that tend to get very complicated. So y is equal to 7 minus 2x. Brought over the 2x. Why am I interested in this? 7 minus 2x. Because now in the second equation, in equation 2, wherever I say y, I'm going to replace it with 7 minus 2x. So we get x squared minus x, see there, times y, but instead of y, I'm going to put 7 minus 2x equal 6. Right? Steps. Solving simultaneous equation. Normally they say where one is linear and one is quadratic. Use the linear equation. Doesn't have to be, but in most cases use this one. Make x the subject or y the subject. Now, wherever I say y, I'm going to replace it with 7 minus 2x. That's what I did here. What you would have done is actually now end up with an equation where you don't have any y anymore. You just have x. But the equation is going to be a quadratic. So here, what we get is this, expanding carefully, minus 7x plus 2x squared equal 6. Right here, you have to respect that this is not a linear equation, this is now a quadratic. To solve a quadratic equation, you're going to bring all the terms on one side equals 0. This, remember, is like a 1x squared. So it's x squared plus 2x squared minus 7x minus 6 equals 0. Simplifying, we get, remember this is like 1 plus 2, 3x squared minus 7x minus 6 equal 0. This is the simplest form you can have for this equation. Sometimes you get like 6x squared 14 and you can divide everything by 2 or something like that. But this is okay. Now, once you have a quadratic, you're expected to get 2 answers. So your next step is to solve this equation. How you solve the equation? You either use factorization or the quadratic formula. It doesn't matter which one you use. In these questions, the one around the back, one linear, one quadratic, it's a guarantee that they're going to give you one that can be factorized. The formula can be used for all, but factorization only works if it can be factorized. So using factorization, which is not the only way, right? So I'm going to factorize, rewriting it here, 3x squared minus 7x minus 6 equals 0. 3 times negative 6, negative 18. Factors of negative 18 that add up to negative 7, negative 9, and positive 2. So we get 3x squared minus 9x plus 2x minus 6 equals 0. Factorize x minus 3 plus 2 x minus 3 equals 0. X minus 3, 3x plus 2, or you could say 3x plus 2 times x minus 3 equals 0. Once you have a product, two things multiplied together to give 0, then it's either one is 0, x minus 3 is 0, or the other is 0. And for each one, you get a little equation now where you're solving for x. So x will be equal to 0 plus 3, which is 3. This should be 3x plus 2 equals 0. You're going to take over the negative 2, the 2 to get negative 2, and divide by 3. So you get 3x equals negative 2, x equals negative 2 over 3. Not finished, because what we have done is to find x. For each value of x, you now need to substitute the value into one of those equations to find y. Which of the equations is most convenient? The first one is convenient. The second one will be difficult, but I tell you, this one is the easiest because you already have y in terms of x. Use whichever method you know, but since y is already the subject, this should be easiest or easy of the three. So I'm going to use my third equation using y equal 7 minus 2x, and I'm agreeing that you don't have to use this. Most of us would probably use the first one here. The reason I'm using this one is I already have y in terms of x. So using this, Then when x equals 3
Y equal 1.
equals 3, y is equal to 7 minus 6 equal 1. And then when x equal minus 2/3, y would be equal to 7 minus 2 times negative 2/3. Is that right? And so what you end up with is 7 plus 4 over 3, which is 25 over 3. Is that what we get? Something so and so peculiar. Check it, Tony. Come on. So I get 25 over 3. Right. So what's the answer? X equal 3, y equal 1. And x equal minus 2/3, y equal 25 over 3. What you're getting is a pair of solutions. So what you're ending up with, the answers, x equal 3, y equal 1. Or x equal negative 2 over 3, and y equal 25 over 3. 25 over 3. Right. Okay. Right. Now 6a. And clearly, that's a little bit of work here. So you want to know what you can attempt in the second section. This question only appears in the second section. Right? The first section, simultaneous, is the one that you can use elimination. This will never appear in the first section. So, optional, yes. Section 2 is optional. So this is an example of a straight option question. Right. In fact, 2b is another example of an option. As completed the square, I selected this one purposely because this one actually has a negative x squared, which hardly comes, but can come. That is 6b. Ready again? Hold on. Now we get 25 over 3 minus 2 times minus 2 over 3 minus 2 times minus 2 over 3. That's like minus 2 over 1 times minus 2 over 3. So when you multiply, you're going to get a plus 4 over 3 plus 7. But the 4 over 3 plus 7 is 4 over 3 plus 7 over 1. LCM is 3. LCM means 3. You work it out. 21. Right. Over 3. Plus the 4 over 3. You get 25 over 3. Okay, LCM. Move in the right hand side here. 6b. Six B. Right, completing the square. That's what this is. 1 Be careful with this one if you are completing a square. What? 1 minus 6x minus x squared. Right? In the form k minus a x plus h squared. Right? Now most of us know the one where the x squared is positive. Is it the same formula that we use? H equal. So what is B and A in this case? Is A1?
Sir, B at 6.
1 minus 6x minus x squared is really the same as minus x squared minus 6x plus 1. Be careful. So if you're using the formula, you should really have it in the form ax squared plus bx plus c. So in other words, be careful, you'll have to have it in this form. For those of us, some students don't have a method to it. Some of us use this formula. For those using the formula, you're saying, here where some of you use this, h equal b over 2a and k equal 4ac over. That's what you use? All right. So if you use it, all I'm saying is where you get the A, B, and C from. You get it from this, from using the equation in this form. Ax squared plus bx plus c. So you have to be careful to make sure it is in this form before you start to say what A is, what B is. So in other words, if you're using this, the A would be -1, not 1. The B would be -6, and the C would be +1. So if you haven't done it yet, do it. Just do it now. While I'm doing it. It should always be in the form. If you have different methods, and this is an example where you really have around 3 different ways. So I'm just using one. This is not a bad way. And in fact, it's a way you can learn it fast if you don't know it. In that, if you have this formula, you can actually find the h and the k and write it down. Because the other part of the question is actually fairly easy. This is the part that can be complicated if you do it in certain steps. There's nothing wrong with doing it this way. Yes, you should always have it in the form ax squared plus bx plus c. If you're going to say what a is, b is, and c, meaning what the coefficient of x squared, x, and the constant. Right? All right. This can I resolve it? No? All right, take a minute.
Serious, sister. So you gotta rub the top of the region.
No, man, good man.
But can they see?
No, they can. They, you? No, it's rough for a belly.
Today is the first day of the week. Finish. We see where you did. So the first one, the number 2.
Right, don't get taken out this side. 6b? Really? Okay. All right, so based on what you're doing, for those of us who use this or learn to use this, it can still be applied. All I'm saying is be wary. Just make sure you have it in the form ax squared plus bx plus c. So in this case, h would be equal to the b over 2a. I'll write it back again. 1 minus 6x minus x squared is the same we say as minus x squared. So it's like a minus 1 plus 6, sorry, minus 6x plus 1. So if you're using the formula, it's like saying this is a, b, c in the formula. So h then is b over 2a, which would be minus 6 over 2 times negative 1. And what you end up getting is negative 6 over negative 2, which is 3. The k is equal to 4ac minus b squared over 4a. So it will be 4 times negative 1 times, what is c? 1 minus minus 6 squared over 4 times negative 1. So k would be equal to 4 times negative 1 times 1 is negative 4 minus 36 over negative 4 is negative 40 over negative 4, which is 10. So h equal 3, k equal 10. And the a, by the way, the a here is always the coefficient of the x squared. So the a is negative 1. So what is it they ask? They ask for h and k, or they say write it down. Write it in the form. So what is the answer? The form would be, so 1 minus 6x minus x squared would be equal to k, which was 10, minus the a would be a 1, x plus 3 squared. No, it's the exact form that you have it.
When we change around, we're supposed to use the change around when we use the original one.
Oh, sorry. No, I just understand what you just said. You're asking if this is 1 or negative 1. This is a 1. This will be a 1.
Okay. But it would have changed if you do the sign there. So
Right.
So it's the original one.
It is the original one. But
No, it's not the original.
Yeah, man, the original one. That's the new.
1 minus 6.
Yeah, because it would have been a positive. It would have been a positive one there.
No, it's not the original one you use. You see, quickly without there are 2 types. One where the x squared is positive. Right? If the x squared was positive and you have like 3x squared or 5x squared or 2x squared, then you know a is just 2 or 3 or 5. The one